All right, this video is going to take us through classifying matter based on its properties. All right, we just spent time talking about classifying matter based on its composition, whether it's homogeneous, heterogeneous, element, compound. Now we're going to look at physical and chemical properties. All right, so this top part is going to be physical. This bottom part is going to be chemical properties. All right, and so these physical properties, let's cut to it's kind of a little bit jumbled. You got to make sure you're in the right spot. All right, so I got like physical properties here. I'll have like physical changes. It's just make sure you're writing it down in the correct spot. I didn't organize it the best. My bad. All right, so physical properties, really anything that is like an extension of your senses. So if I asked you to describe something, I'd be like, hey, what would you use to describe that tree or that object? Like, oh, the tree is tall, it's green, if I asked you to describe like a diamond, you might describe its color, how its hardness, its whatever. These are more descriptive terms of matter that doesn't involve any kind of a chemical change. All right, so what color it is, its melting and boiling points, changing the state of matter that it's in. All right, it's a liquid, it's a gas. All right, oh shoot, my bad. It should just say states of matter. What state of matter is it in? Changing states of matter will be obviously a chemical or a physical change, but the state of matter it's in, it's a liquid, it's solid, it's a gas. How hard it is, how malleable it is, how malleable is just the ability to shape something, to hammer it without it shattering, to bend it, mold it. Gold is so valuable because it's easy to bend into pretty little pieces of jewelry without it breaking. Density, how compact the particle is. Solubility, that's the ability to dissolve something. I think I spelled that wrong. Viscosity, the flow, how much a liquid can flow. Some can flow very quickly, some don't. Like corn syrup, it doesn't flow very much. Conductivity, the ability to conduct heat or electricity. These are all physical properties. All right, they don't change the substance itself. It's just a description of what they are. Physical changes, so something is changed. Property has changed, but the substance remains the same. So physical properties and physical changes, it's describing its characteristics. Physical change is when a substance changes, but it doesn't really change. It just looks different. All right. So like when you melt an ice cube, that didn't change. It's still water. It just looks different. You freeze water, it didn't change. It just looks different. It's still water. It doesn't turn into something new. You cut something, it's a piece of paper, you cut it into two, and now it's just two pieces of paper. Dissolving is another one that's oftentimes thought of as a chemical change. That's a physical change. All right, when you dissolve something, if I dissolve sugar, if I'm making hot chocolate, I dissolve that in there. I'm not changing it. I still taste chocolate and milk, or chocolate and water if you're a weirdo and make your hot chocolate with chocolate and water. But it's not changing anything. It is just dissolving one thing into another. I mix salt and I mix water. I mix it up. It might all look like one substance, but it's not. All right, and you can also use these properties to separate a mixture. And we're going to actually do this in a lab later on. All right, so filtration. I love coffee. Coffee's like my thing. I like to brew my own and everything. Not into it as much as corn, but I do like roasting my own coffee. Filtration is a way to do it. You do that every morning. I do this every morning. I put coffee grounds into a filter paper. I pour a liquid on it. The liquid pours over it. The liquid is able to pass through the filter paper, but the solid particles are not. So it's a good way to separate solids and liquids, to keep the solids from entering into where the liquids are. So filtration is a good method of using to separate that. Using properties to separate, another way to do it is particle size. If you've ever cooked anything, a lot of time, like you ever cook something like noodles, that's an easy way. You got your noodles are cooking on the stove, I should say, and you need to drain them after they're filled with water. Well, the easy way to do it, you just grab a strainer. You put the noodles in, the strainer will catch the noodles, the water will pour through. All right, so you can separate that mixture by using the particle size. The smaller stuff will pass through, the larger stuff will be caught. And this can be done with solids as well, like sand. Who didn't play with this as a kid? I always had one. Ours is yellow. That's why I always feel like it's yellow. But you just scoop a bunch of sand up and it catches the rocks and the mulch or whatever else got thrown into the sand, but the sand is able to pass through it. So you can separate based on the size of the particles. You can also use physical changes to separate. All right, so here's an example. Evaporation is good because it can be used to separate a solution. So like if you this is a solution, I don't know, it's like copper 2 sulfate mixed in with water. Well, you can't filter that out because if you can see right here, it doesn't you can't see anything. It all looks like one substance. That's what a solution is. A solution is when something is so evenly mixed, you can't see it with a microscope. It will pass through filter paper. And so the best way to separate something when it's a solution, like if I had salt and water and I poured it through a filter, it would still be salt water because the salt would just pass right through it. It's attached to those water molecules. So what you have to do in that case to separate is to use evaporation. So you'd boil it away. Here you can see some of it's getting boiled away. Some of the solid particles that are mixed in are now starting to fall to the ground as it boils. From here to here, it goes from one substance to now I can start seeing some stuff. And then when all the water boils away, you'll be left with that solid, that crystallized solute, that stuff that was mixed into it. All right. So evaporation is a good way to use it. Another one is distillation. This is a good way to get the original liquid back. It's really hard to see. There's a beaker there. You got to trust me. Basically, you heat up the water will evaporate, and then as it rises up, it will cool, and it will condense, and it will go down and come back into water. Once it goes back down into this condenser, cooling the water, and it will come down into the beaker. So it's a good way to separate, if you got a solution, same thing. It's similar to evaporation. You boil the water, and the water will then just come back down this cooling tube and back. So you'll have pure water here and salt. The salt will remain in here. So it's a good way to separate something that's mixed. Chemical properties. On the other side, this is something that has the ability to produce a change in its composition. So you get a whole new substance. So chemical properties is when you get an entirely new substance is formed. Reactivity, how easily something reacts. A lot of times with the air, like oxidation, how much something reacts with the air. It can tarnish like silverware. Sometimes your silverware gets like these weird spots on it. It's because it's reactive. It's reacted to the air. Your car has got rust on it because it's reacted with the air. The oxygen in the air, and it produces a new substance. How flammable something is, the ability to catch fire. Combustibility, combustion, for how easily it can explode, blow up. Toxicity. These are all examples of chemical properties that can produce a new substance. All right, a chemical change. Now, these are examples of chemical changes when a reaction creates a new substance. All right, so an example. So a new substance, something new is created. Car rusting. Cooking an egg, anytime you cook something, you might think that's not a new substance. I have an egg and now I still have an egg. But remember, whenever you cook, that's why you have to cook meat, because if you just eat raw meat, you could get really sick. And so cooking something, it does change its composition, so it makes it so it's safe to eat. Food spoiling, same thing. Campfire, and the easy way to look at this is, can I undo this? All right, can I undo this chemical? I can't just if I melt an ice cube, I can put it back in the freezer and it will freeze again. All right, I can't take all the ashes and put them in the freezer and it'll come out of a log. All right, because a new substance is being created. All right, because that flammability that caught on fire, that fire produced something new. All right, and identifying chemical change, how can you tell if it's chemical or physical? A lot of times, color is a good indication. You see this black spots on food, or that's mold. You can't put that in the fridge and it undoes it. All right, car rusting is another good example. The color has changed. So that's a good indication that a chemical change has occurred. Now, not always. I put food coloring in something, or I put chocolate powder into into my milk to make hot chocolate. That changes its color, but so it's not always the case, but in these cases where you're not introducing something new, these are good examples of color change. Gas production, when you see bubbles forming, that's usually a good indication that a chemical reaction has occurred. If you didn't have bubbles before, now all of a sudden you do, that means gas is trying to escape, and gas has been formed. All right, and so when you're looking at a physical and chemical change, sorry, I know this is a lot writing, you got to ask yourself, is a new substance created, or is it the same substance and just in a different form? All right, so physical changes typically involve like melting, boiling, dissolving. Those are all examples of physical changes. I'm not changing the substance. I still have the same two substances that I had, or same substance I had. I'm just changing what it looks like. All right, or a chemical change, whereas a chemical change is I have an entirely new substance is being created. All right. So if we go through this list and I say, all right, hey, we got water boiling, what would that be? Would that be a chemical or a physical change? Dissolving sugar into water, is that a chemical or a physical change? Do I have a radically different substance there, or do I just have sugar and water? All right. Hint, that's just a physical change because I'm dissolving it. That's an example of I don't have a radically new substance. I just dissolved sugar into water. It's just sugar water. All right. It's largely the same. Burning wood, we already talked about that. Breaking glass. All right, is that a chemical or physical change? Is that a new substance, or am I just changing what it looks like? Iron rusting. All right. Chopping wood. Do I have a new substance, or am I just changing what it looks like? All right. So those are things that you want to ask yourself, and just answer those at the end of the puzzle there.